Hi, everyone. Thanks for coming to the first Radiosoft webinar on Sirepo. My name is Stephen Webb. I'm a research scientist at Radiosoft. I'll be running this webinar. Also on the line is Chris Hall, who is also a research scientist at Radiosoft and our resident elegant power user. He'll be answering questions. And our product manager, Paula Messmer. Just a couple logistics. If you're unfamiliar with the Zoom webinar interface, I assume you're familiar with the Zoom interface. The panel on the bottom, there's a section on Q&A. So if you have any questions throughout the webinar, just throw one in there and we'll pause a few times to take questions and answer them. We are also going to be doing a few polls through this, so you'll get a pop-up window on those things. And also, if you want to follow along, now would be a good time to go to sirepo.com and get ready to sign in. So we have, all right. So I will now share my screen. All right. So for those of you who are not familiar, Sirepo is an open source framework for building browser-based apps for various scientific codes. Today we're going to talk about the tracking code Elegant. So everything we're going to do is running Elegant under the hood, but it's all through this browser-based interface that we built for it. So if anybody wants to follow along, the URL is just sirepo.com. This is the landing page. There's a lot of information on here on the codes that we run, from particle accelerators and X-ray beams, plasma accelerators, things like that. So if we, I'll have to move some windows here, but if we go to the supported codes, you can see the codes that we have built apps for. There's Scooby, which is a particle tracking code that includes spin. There's warp plasma-based accelerators and warp vacuum nanoelectronic devices. This might be useful for things like thermionic guns, for accelerator applications. There's JSpec, which is an electron cooling code. Opal, which is a gun code. It's right now we support Opal T. We do not support Opal cyclotron just yet. Shadow and SRW, which are X-ray beamline codes. Synergio, which is a space charge tracking code for ion and proton beams. And what we're going to work with today, which is Elegant, which is an electron tracking code. So if you're following along, just click on supported codes and click on Elegant. And this takes us to the Sirepo landing page. This will show you all of your existing Sirepo simulations. This is as organized as mine has ever been. Up at the top here, we've got new simulation, new folder, and import simulation. We'll get to all of these at various points in the webinar. So I'll go into my demos folder. I've already got one example, but we're going to start with a new simulation. Before we get going with this, we'd like to find out how you guys use Elegant for your simulations. So if we want to just take a minute to answer this poll question. All right, we'll give you 10 more seconds. All right, thanks everyone. So we will begin by creating a new simulation, and we're going to start with the first example most accelerator physicists learn, which is a FODO cell. So across the top here, we click on new simulation. I'm going to call it FODO, and I'm going to add as a note, FODO cell example for Sirepo demo. And that's now created. All right, whenever you log in for a simulation, it drops you into the source tab. For this simulation, the source tab isn't particularly useful because we don't have a source yet, but we'll explore this a little more later on. Let's go to the lattice tab. So the lattice tab is where you set up your beamlines. So first thing I want to do is create a new beamline. So I click on this new beamline button here and it pops up a window asking me for the name of my beamline. I'm just going to call it FODO. Actually, I'm getting tired of calling everything FODO, so I'm going to call it my FODO. Save changes, and now I have a beamline. It's completely empty, but that's okay because we're going to fill it. The first thing we're going to do is create drift. So we go over here, over the new element button and click that. And it shows us, first of all, a couple of common basic ones. So we've got quads, drifts, CSR, CS bins, CSR drifts, sextupoles, kicker, wiggler, watch points, markers. But we're starting with a drift. So we're going to click on drift, and I'm just going to give it the name drift. And I'm going to make it 1.3 meters long. And I'm going to highlight, number one, we've got over this little eye here. If you hover over that, we have the documentation for Elegant has been scrubbed. And if you just hover over these things, it'll tell you exactly what it is. So matrix order, group, for example, and length. For a drift, it's not terribly complicated, but we now have a drift. Save changes. So now I have my drift. If I want to add it to my beamline, I click on it and I drag it over down to this beamline editor panel to the bottom left, and I put it in. And in the lattice panel up here, we see that it's appeared. It's all to scale. So the scale is 10 centimeters here. It was 1.3 meters, so it's 13 of these across. I can collapse this panel by clicking hide, but I don't really want to do that right now. Another thing that I can do is I realize now I need 3 drifts. I need a full drift and a half drift. And something that's really useful is I can define a variable. So if I click on this variables button over here, right next to the new element, I can click here and I can define a variable name. And I can call it, for example, LDrift, and I can call it 1.3. And then I can save changes. And now I can go back into drift and I can change L to LDrift. It says 1.3. It shows me the numeric value off to the right. So this makes it easy to change around. If my lattice has a few parameters that everything depends on, it makes it very easy to self-consistently change it within the lattice. So now I click Save Changes, and now if I hover over drift, I can either create my half drift by clicking New Element, or I can come over here and click Copy. If I click Copy, I get a duplicate of that drift, and I'm going to call this one half drift. And I'm going to make its length LD over 2. And so now I have a half drift and a full drift, and I can drag that over here. And you'll notice that this all says drift under name here. This is a collapsible list, and we'll get to how that's sorted later. So now I have drift, half drift, half drift. And then the other thing that I need for a photo cell is a quadrupole. So I click on New Element, I hover over Quad, and it tells me a quadrupole implemented as a matrix up to 3rd order. So I click on that, and now I've got a quadrupole, and I'm going to call this QF, and I'm going to make its length L quad. And then it yells at me because I haven't defined L quad yet. So I'm going to cancel that out. I'm going to go into variables. I'm going to define L quad, and I'm going to make it 10 centimeters. And I'm going to define K quad, and I'm going to make it 2.5 per meter squared, anticipating this. And I'm going to note something here, which is I can also define variables in terms of basic functions of other variables. So for example, I can say cos KQ LQ squared. I don't know why you would ever use this quantity in a physics thing, but it's demonstration. But I can say cosine of KQ times LQ times LQ times LQ, close parentheses, and it shows me what the cosine of that is off to the right. It's a numeric value. I can also take the exponential of it and get the same thing. I don't really need this, so I'm going to get rid of it. so as not to clutter my namespace. But you can name your variables whatever you want and then use them consistently. So now that I've got the length of the quad and the strength of the quad, I can create my quad. I'm going to call this again QF. I want it to be LQ, and I want it to be KQ, okay? And then now I've got the quads and the drifts sorted by the type here, so I can collapse this. I can collapse this by clicking there. And then I can also duplicate my QF as a QD. And then I just flip the sign on KQ. And now I need a focusing and a defocusing. So I just click and drag, click and drag. And this is not obviously a photo cell because I have drift, 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 quad, quad. So if I want to rearrange these, I can just click and drag my QF over here. And I can move my half drift over here, and I can move my other half drift before here. And now this looks like a photo cell. And you'll notice if I click on this in the beamline editor, this pops up and it highlights what I've clicked on. I can similarly come up here and I can double click on the quad and it will pop up QD, and I can make changes here to my quadrupole. I can make this times 0.9, for instance. I can click on twist parameters and it will compute the twist parameters for the lattice. All right, so we can see the twist parameters for our lattice here. I've got eta x, beta y, beta x. I can click on this little tick box here and take eta x off. I can also edit my twist parameters. I can make this none, for example. I can show lattice overlay, so if I turn that off, there's nothing up here, but if I turn it on, there it is. I note that for these beta functions, right now for elegant, it's dumping at the beginning and end of all the elements, which is why this is a piecewise straight line instead of a parabola like you'd expect. So if I scroll down, or if I close this and go back here, I can undo this. And then we also have the control tab, which I'll get to in a moment, and the visualization tab, which I'll get to in a moment. Once I'm done creating this example, I can share it with someone. So I can click on this button up here next to photo. Here I can rename it. I don't want to do that. And here I click it and it shows me this, this URL, which I can copy. And if I go into my chat, if I can, number one, if I can make the chat window appear, there it goes. If I go into our chat window and I go to all panelists and attendees so that I can send this to everyone, and I paste this URL here, every one of you can click on this URL and you'll get the same photo cell as I just created. You'll get a copy of it in your own local Sirepo working space. So now that we've done a basic photo cell, let's take a look at something a bit more complicated. So I'm going to go into simulations. And I'm going to go into photo opt. So actually, let me show you this. If I click on this, it drops down all of my options. So I can move it, I can rename it, I can open a new copy. One thing I'll note that right now, Sirepo doesn't have version control or history on the simulation. So if you get to a stopping point, it's best to make a copy of that if you're going to make changes. I can export it as a zip, which we'll get to in a moment, or Python source self-extracting. So I want to click open. And I'm still in a source tab. We don't really have a source yet for this either, so it's showing up as a zero emittance dot. And we'll show something a little better later. So I can go into my lattice here, and I've got another photo cell. It's got slightly different parameters. I can compute the twist parameters here. Same jam. Takes a moment to simulate. By the way, all of this is simulating on Sirepo, on Radiusoft servers, running Sirepo. It is possible to stand up Sirepo on your own local server as well. So here's the beta functions. I've mussed with the quads a little bit, so they're a little asymmetrical. And I can go into the control tab, and this is where I basically have control over all of the .ele input, if you're familiar with that. So one of the things that we can do, we're setting this up for an optimization, as the name photo opt suggests. So here's my run setup. I can edit this, and if I go in here, I have control over everything that Elegant is going to dump these SDDS files. Again, if you hover, you see the name of an SDDS file to which this is going to be exported. These are default values. I can change what beamline I'm using. This only has the one beamline. And it has everything, I believe, that you can do with Elegant, you can do through the control tab. So it's got print statistics, wraparound, random number seeds, things like that. Up here, you can control the output, and then when we get to the visualization tab in a moment, you'll see where this comes into play. Save changes. The other thing that you can do is create a new command. So I can click here. I've already set up the optimization, but if you hover over the optimization setup, you're able to set up an overall optimization using the built-in Elegant features. So to see how that works, if we go into, for example, optimization setup, I click on this, and it shows me everything that I need to do that I would need to specify in the .ele file. So we've got the tolerances and the target and all of that. I'm not going to mess with this because it's already working. For the optimization term, I can click on this, and I can specify the term. I can use reverse Polish notation, which Elegant understands, or we can use Sirepo expressions. And I can weight these different optimizations. I can have the input files if I need to specify input files. I can define variables. All of that is controlled through the control tab. And so, you know, what I save the lattice as, my run setup, my run control. And then if I go to my visualization tab and I click start new simulation, this is now running on our servers. We're running Elegant on our servers. And once my simulation is done, it's only 5 seconds because it's a 5-element photo cell. It shows me all of the characteristic output, all of the characteristics that Elegant does for the new lattice. I can scroll through all of this. Here's my run setup output. Again, we don't have a beam for the inputs, so we're not really seeing anything there. I can collapse this, I can collapse this, I can collapse this. And then it will show me the initial twist output, which I showed you earlier. And then it shows me the output once we've run the optimization scheme on the twist parameters. So that's what it looks like if you run this optimization. And so before I move on, now might be a time to look at a few of us. We've got a couple questions. If anybody wants to pause for a second and ask any questions, now's a good time to do it. All right. Where to define the beam parameters? You would define the beam parameters either in the control tab. Actually, Chris, why don't you handle this, because you're an expert in this, and I know it's a tiny bit subtle, or it can be. Chris?
Sorry, I had to be unmuted there. Yeah, so for defining the beam parameters, that was the question, I believe?
Yes, question from Sarvesh, where to define beam parameters?
So the way you can do that interactively is under the source tab, which we've kind of just skimmed over so far. You can see you can set through the twist parameters there at the drop-down, or even import a predefined bunch. For more options, see where you click on the pencil icon, you can briefly show the full interface here for defining distribution types, the emittance, which also lets you set the twist parameters individually, and then there are other options for describing how the distribution will be sampled. All this is actually working through the bunched beam name list for people who are familiar with that. This just provides a more interactive way to do it. You can also separately go into the control tab and click on bunched beam, and all the settings that you're putting into the bunch tab will be mirrored over there, or you could also optionally set them directly in the control tab and then go back to the source to see a preview of what changes you've made.
Right, okay. I've got some windows in the way here. All right. All right, so we're going to, we'll move on to the next bit, which is uploading an existing elegant file. So let me just move, I've got a couple windows open. So if I go back to simulations and click on simulations, I've got this option here that says import an elegant command or lattice. Or this import button here, I'm going to use this. And it's going to ask me for an ELE file, an LTE or MADX file, or a Sirepo export. We're not going to get to Sirepo export, but if you're running Sirepo simulations and you want to download, an option is to download this zip file. And if you have that zip file, you can just upload that zip file and it will recreate the Sirepo simulation. So if I click on choose file, you probably can't see this, but it pops up a file browser for me to pick something off of my, my computer. And I have got something from the par ring. So I'm going to open up a file called partrack.ele. So this is from the elegant examples. I click import file and it reads that file and it says, okay, I need a .lte file, a .lattice file. So I click on choose file again. I find my .lte file. I open it, import file, and there it is. This is the par ring. Similarly, I can click on twist parameters here. Pops up the twist parameters. After it simulates the lattice, it's a little bigger lattice, so it takes slightly longer than a photo cell. We've got our dispersion in the horizontal. We've got beta X and beta Y for the par ring. I can scroll in and out. So if I have a particularly large lattice, I can scroll right or scroll up, scroll down with the mouse and zoom in, zoom out. I can click on this pencil and I can change what I'm plotting. So if I want to look at the phase advance, for example, change that. And if I want to get rid of the dispersion and I want to get rid of my show lattice overlay, I can turn this off, save changes. So there's my phase advance over a single turn. Close that. Another thing that I can do is I can download this image. If I hover over this cloud with the arrow pointing down here, it prompts me for a download. I click on that, and I can download it as a PNG. So this is a slightly more complicated lattice. It's got this MAL element, RC. It's got a half. It has another half, an AP, and a W1. Something I might want to do when I get these lattices is deal with these beamlines. So Elegant has this concept that makes it very easy to control groups of elements called a beamline, but they can be a little difficult to manipulate in a larger lattice or when you start to get a few deep. So one of the options that Sirepo has is I can manipulate my beamline. So if I go over half and I right click on it, it pops up a few options. I can unpack, I can reverse, or I can cancel. Reverse is an Elegant feature. It flips the order of the lattice essentially. Obviously, since this is a ring, flipping the order of the dipoles is a catastrophe and it's no longer a ring. So I'll just put that back. Or I can unpack. And if I click unpack, it takes the beamline that was half, which if we click here and click on, if we hover over half over here on the right and click on edit, it just shows me what half is. And so it's made up of 3 more beamlines, quad R2, SF, and minus quad R2. And so if I want to start editing things inside of these beamlines, I can unpack the beamlines automatically through Sirepo. So if I go back to editing par, I've broken half into quad R2, SF, and minus quad R2. And let's say I want to put a, so again, if I click on this, it will highlight in the ring where the element is, and I can double click on the individual elements. So if I want to add a watch point, for example, in between SF and minus quad R2, I can go over here. I can scroll. Oh, sorry. I can scroll. Why is it not scrolling? Okay. There it goes. I can scroll down, click on new element. I can select a watch point. I can call it my watch point, because again, no one is ever going to call their variable my something. Save that. And if I want to find the watch point, it's just under the W in the alphabetized list of elements. Here's my watch point. I'm going to move it over into quad R2. And then if I want to repack this as a beamline, I can click here. You know, I'm clicking and I'm seeing all the highlighting. So I can click on quad R2, and then I can hold down shift and click on minus quad R2. And you know, when you're working with a text editor and it says, and you want to select text on a line, and you click here and then you shift click and click on the other right side, it's the same concept. So everything between quad R2 and minus quad R2 in our beamline editor will now get caught up into what I'm going to call my half. And now I've got my half over here in the beamlines, so I can edit that. And you see that it's the same as half, but it's got my watch point added to it. And so I can manipulate beamlines in larger lattices like this. And if I want to unpack it and click on this, I can hit unpack. I can also unpack quad R2 as well. If I want to get rid of the watch point, I can just click on the little X next to it. So if I hover over it, it gets this little X here. I click on that and it deletes my watch point from the lattice. And then I can just repack this if I want. Let's move this back over here. And I'll call this my half. Save changes. So if I go back to the source tab, which I promised I'd get back to, I've already preloaded this SDDS file, but in the process of those prompts for files, if you have an external bunch that your imported file requests or your imported simulation requests, it'll prompt you for this file too. So I've got a bunch of different sources here. I can download it. I'm looking at the actual input here. This is a relatively small number of particles. So it shows the cross section, X and Y. It shows y prime, xx prime, and the longitudinal phase space. In principle, if I'm generating the distribution from an elegant distribution, say a Gaussian distribution, this would prompt me for the number of macroparticles to specify, things like that. So if I go over to the control tab, it's a pretty simple control tab right now. And I go to visualization. I want it to simulate the par beam line, and it's going to do that with this source. I click on Start New Simulation. And it runs the simulation. Again, it's small lattice, doesn't take that long to run. I can scroll down. It shows me all of the elegant output. So I can collapse these output parameters. I can look at my watch points output. It shows me X and X prime. I can change what it's looking at. So X, XP, I can look at Y, Y prime as well. I can change the color map to, say, Viridis. I can make a note that this is from my watch point. You can save that. And it changes the plot around here. Same deal as before. I can scroll in, scroll out, and I can zoom in, zoom out. I can also download. And in the case of the output, I don't just get to download the PNG. I also can download the raw data file, which in this case will be an SDDS file, or a comma-separated variable data file, so that if I have some post-processing tools of my own, say in Python or MATLAB, I can download these files and manipulate them on my local machine if I don't have what I need out of this. I've got my TWIS output, my beta X. I can change that plot as well. I can also look at beta Y. I can show a lattice overlay, and there it is. And there's also another watch point called W1 that I can edit as well. If I want other information out of my simulation, I can go back to the control tab. I can click on new command. So new command is right here again. I can click on that. I can add, let's see, advanced. Where, let's see. Oh, no, I'm sorry. This isn't a new command. This is in run setup. So if I go into run setup, right now my output is essentially 0, and my centroid is 0, and my sigma is 0. So if I want my beam sigmas, I would go down to here. This is set to none. I would set it to run setup.sigma.sdds. And same with the centroid, I can do that. And with the output, I can do that. And I can click Save Changes. And then I go back to the Visualization tab. I need to run the simulation again because that data didn't exist before. So I run my new simulation. And now I've got all of the other information that I requested from Elegant. I've got the beam centroid, CX. I can change this over to CY, show a lattice overlay. So this is the centroid files output. This is the sigma files output. So this is the beam, these are the beam sigmas. If I click on this, this marker here, I can edit it. I can pick what my sigmas are, can show a lattice overlay, save changes. Here it is. I can similarly download with a CSV file or the PNGs for all of this, and it includes the lattice as well. If you want to compare, for example, the centroid to the sigma, right now you have to download the CSV file separately and do that on your local machine. So let's see. So this is, we've covered the visualization tab, the source tab, the control tab, and how to do imports and the prompts. So before we move on, we want to ask one more another poll question. Tell us a little bit about how regularly you use Python in your workflow. So this is answer as many as are relevant. I'll give you a minute or two. And give me a chance to rehydrate. And also, if anybody has any questions about what we've just done, you know, keep on asking. We're happy to help, and if we can't answer your question here, we will definitely follow up with you by email afterward. All right, so thanks everyone for filling that out. So the next thing I'm going to show is a little bonus material for you. Radiusoft not only hosts Sirepo, we also host a Jupyter Lab server. So when you're running your simulations in Elegant or Warp or what have you, we support the ability to also download the file, which you can do over here. If I click on this little wheel here, I can export as zip, Python source, export as MATX lattice, which is a new feature. It's still getting a shakedown, but in principle, you should be able to download your MATX as a lattice, and if you run into issues with that, please let us know. I can also do simulation documentation, things like that, but I'm gonna export as a zip. And then you're probably not seeing this, but it's asking me where I want to download my zip file. So I'm going to pick a directory on my local machine, save the zip file, and then I'm going to come over here. if you go to jupyter.radiosoft.org, this is a free service that we provide right now. It is a scientific Jupyter interface. If you're familiar with Jupyter Lab, that's what this is built on, or Jupyter Hub. So again, jupyter.radiosoft.org. The login right now is different from the Sirepo login, so you would log in with a GitHub account. And if you do that, you will pop up for the first time with a launcher, and it will prompt you for, do I want to create a Python notebook or Python 2, Python 3, terminal, text file, markdown, and contextual help. A couple things about this container. This container contains every code that we support in Sirepo. So in principle, you can run Warp, Elegant, Scooby, Opal, SRW, Shadow, all through the command line over here. And it also supports a few codes that we don't currently have Sirepo interfaces for. For example, the Genesis FEL code is supported here. I believe the FBPIC plasma accelerator code is supported here. But we'll get to that in a later webinar. So if you get to a point where what you're doing over here in Sirepo just isn't what you need to combine, you want to compare, you want to plot centroid versus sigma, for example, or something along those lines on the same plot. You need to do some more advanced Python manipulation. We have a full Python scientific library here. We have the usuals, NumPy, SciPy, Matplotlib, Seaborn. We also have machine learning libraries like GPFlow and TensorFlow and Keras are all supported here. So I'm going to create a terminal for now, and it's just going to pop me up in a new terminal here on Jupyter. This puts me in my home directory, which is home/vagrant/Jupyter. You can see all of the good work that I'm doing in these different directories. So I'm going to go into demo, which is empty. And then I'm going to open up in my local Finder, and I'm going to navigate over to where I downloaded my zip file. And I'm going to just click and drag over in, if I can click, I'm going to click and drag over to this file browser to the left here, and then I'm just going to drop it in there. And now I have uploaded the zip file, so I can unzip that. And you see everything that was generated by that simulation. So you've got Sirepo-data.json, you've got you've got the support SDDS files that you needed for this. You've got something called run.py. So without getting into the JSON file, let's go into run.py. And you see this, this big file. And what this is it's a Python file that contains everything that Sirepo needs to generate the simulation. So Sirepo is running a lot of Python in the undercarriage. And so this is all, if you can read this, which you can, because a lot of this is just elegant, you can go into the run.py file and you can make modifications to your simulation inside this run.py file. Here's the information for the .ele file. Here's the information for the .lte file at the top here where it says lattice file, and then elegant file here. And then it's, it defaults to creating elegant.lte and elegant.ele. And if I go back over to this tab here, terminal 4 is what it's called on my machine, and I do Python run.py, it creates the elegant simulation source, and it runs the simulation. So you can see that down here. At the bottom of the run.py file, it creates my .lte file, which you can see over here on the left. It creates my .ele file over here, and then it uses Python's os.system to launch an elegant simulation. Now, if I want to name it something different, like I want to say my par lattice, and well, this is asking for trouble actually, but I can change this to my par sim.ele, and I can change this to my par sim.ele, save that, come back over here, run the same Python command, Python run.py.
You had a spelling mistake, Stephen?
I did? Uh-oh. Yes, I did, and that would be why it showed an error. Thank you, Paula. So if I run this live demonstrations, so if I then run this, it runs the same simulation. You'll see over here that I now have myparsim.ele. If I want to change the file names in here, so for example, if I want to change the name of elegant.lte, that appears under the lattice up here, and I would have to go in and change that manually, but you can change the simulations you want to run through this terminal. And again, if you have some sort of advanced optimization run, or you want to do some more advanced post-processing, and you reach the limit of what you can do in Sirepo, Jupyter Lab is Radiosoft's Jupyter Lab server is available to you right now free of charge. And you're welcome to play around in there, move your simulations over. If you've got a lot of Python chops, you can do a lot of work in here. You can do basically anything that you need to do in Python. And if you're relying on some library that we don't currently support, you can certainly put in a request and we'll look into adding it. So with that, that concludes the demonstration part. So if anybody has any questions, please let us know. Thank you. Right. Which Genesis version? Good question. Let's see if I can get that. Version 1.0, it appears. We can, but that can be changed. We've built Genesis before, and if you need a more, oh, I'm sorry. There's one last poll I wanted to ask. So while we're fielding questions, we've got a poll about what you think of Sirepo after this. Do you think Sirepo will be able to help with your workflow after this demonstration? And as regards to the question with which Genesis version, appears to be version 1.0, but this is driven by a specific project, so we can install different versions of Genesis if we need to. You just need to ask. So we had a couple questions that came up. One of them was about standing up Sirepo on a local cluster. We do have a few questions, and we do have some documentation on how to do that. You can contact us with support, and we are also happy to do that for a consulting contract. So if you want us to set it up kind of start to end, we're happy to do that as well. Okay, are Conda environments supported? Conda environments, I believe, are supported, but this is all in an application container. So every once in a while, we have to restart the container and you're gonna have to rebuild the environment. So that's a good question, Nicole, thank you. Chris, am I correct on that?
You should be able to set up a Conda environment. Yeah, obviously, if you stop container or log out of Jupyter, then it will be reset. The question, we already use another local environment manager, but I don't believe they conflict.
Mm-hmm. And Dennis Turner has a question: is Pelican supported through Sirepo? Yes.
Yeah, you can, Stephen, if you want to go back to the Sirepo tab, we can show how to set that real quick.
Yeah, let's do that.
It's under the visualization menu. Yep. And then edit, run. Yeah, so you can select serial or parallel.
Right.
Parallel obviously being through Peligant.
Right, so to slow that down a little bit, to set up a parallel elegant simulation, you go into the visualization tab, which is also where you control your the actual simulation. You go over to the simulation status window, you click on the pencil, and then it gives you the option of serial or parallel. Backtracking is an option, so you can start at the end of the beamline and go back to the beginning. So that's where that option is. So everybody will be receiving an email at the end of after this with a copy of the video of the webinar, so you'll be able to look at this again and slow it down. I'm going to type my email address into the chat window. So if you run into any questions, you should feel free to ask me. And I will get back to you as quickly as I can. So thank you all for coming. I hope this was informative. This is the first in what we hope will be a series of webinars on Sirepo and the various Radiusoft capabilities. So look out for future emails for different codes and other webinars where we're going to talk about some of our technical work as well. So thank you all again, and I hope you all have a very nice rest of your week.